So again, last reminder, projects are due next Wednesday. You have a Unit 6 test this Friday. Okay? We're going to keep going with Chapter 6. We're going to do 5 today. We're going to warm up using some stuff we did in 6-1 that's going to help us with what we need to do in 6-5. We talked about vertex form in the very beginning. Okay? So in my vertex form, we were given an equation. There was what letters were used for my vertex? For just the vertex, though, it was H and K. All right. What did the H represent? The X, and what did the K represent? The Y coordinate, not the intercept, the coordinate of the vertex. Okay. What is a vertex when it comes to a parabola?
The top or bottom point of the parabola.
So it's either the highest point or it's the lowest point. Okay. So when we're talking about vertex, here we go. It can either be the lowest point down here, or it could be the highest point up here. Okay, that's our vertex. We were given a vertex equation at the beginning. It is y equals, or f of x equals, same thing, a times x minus h squared plus k. This was my vertex form. Okay, so looking at f of x on the screen right now, which of those gives you your a value? Is it the 2, is it the 4, or is it the 3? It's my 2, okay? Is 2, how do I determine if it's going to open up or down? If it's positive or negative, good. So what is 2 this time? It's positive, so we know it's going to open up, right? Now the vertex, we're pulling out our h and our k. When we pull out h and k, something happens. Use this marker. Okay. My vertex is just hk. But what is h in my equation? What's attached to it, though? There's a negative, right? When you pull it out of your equation, you are always going to change your h, okay? But your k will remain the same. So you will keep your k, but you will have to change your h. So here, right now I have x minus 4. So what is my h going to be? Positive 4. Good. I have a plus 3 on the end, so what is my k?
A negative 3.
A positive 3. We change our h. We keep our k. Ladies, are we done? I got plenty of empty seats that I can use to separate you guys. Let's move down to h. So I have 1/2 times x plus 7 squared minus 5. All right, what is our a value? 1/2. So is that positive or negative? Positive. So which way is it going to open? This one's going to open up also. Look like this. So even though 1/2 is a fraction, it's still a positive number, right? It's going to open up. All right, what is our vertex going to be? My h is, always change your h. Always change your h. Always change your h. What is my h? Negative 7. What is my k? Negative 5. Always change your h. Always keep your k. All right, how about g of x over here? What is our a value? Negative 2. So what does that tell me about which way it's going to open? Down this time because it was negative. What is my vertex? My h is negative 4. What is my h? What is my h?
Negative 4.
Okay, 3 people know it. What is my h? Negative 4. What is my k? Negative 3. You always change which one? Your h. You always change your h. Okay? Change your h, keep your k. So our vertex is going to be negative 4, negative 3. And like we said, because my a value was negative 2, it's negative, it's going to open down. Okay? M. What is my A value? A -1. So it's going to open which way? This one will open down. Okay? What's going to be my H? +5. There's more people that time. What's going to be my H? What's going to be my H? Thank you. What's going to be my K? 0. There's nothing there. Right? There's nothing being added. So what's my K? 0. So we have an H of 5, a K of 0. So all those vertexes are showing you where these maximum or minimum points are.
So if it's x, can you just say negative x and positive x?
What do you mean?
Never mind.
What do you mean if it's just x? Like in the parentheses?
Yeah.
Then it's 0.
Oh.
Your vertex is not a letter. Your vertex is the number. All right? Remember vertex stuff? Because now we're going to work with vertex stuff. So to refresh one more time, HK is the vertex on the graph. That coefficient, which is A, determines if we open up or down. So a positive A is going to open up, and then we said negative A is going to open down, right? New thing, the A value itself is going to show a stretch or a compression. That's one of your questions tonight, okay? So there are 3 situations that can happen with your A values. If A equals 1, meaning you only have an x squared, okay? There is no stretch. There is no compression. Okay? It did not get altered if your A is 1. And you should all already know what your A is equal to for your projects. Okay? Situation number 2. If your A value is bigger than 1. So if you have a 2x squared, a 3x squared, a 1.1x squared, anything bigger than 1, okay, that is going to give you a vertical stretch. Okay, meaning your parabola literally gets stretched up and down. So it's going to be a little bit more narrow. So this is nothing changing. The vertical stretch is getting pulled up, so it's going to increase and decrease faster. Okay. The third option is if we are in between 0 and 1. Okay. Because to go below 0 means you go negative, and that's not even vertical or compression anymore, right? Positive and negative tells you up or down. Positive or negative does not tell you stretch or compress. So just the number A, just that number. If it is less than 1, so 0.5, 1/2, 2/3, right? 0.25, whatever. That's going to be a vertical compression. So that is part of your homework tonight, is to determine if you have a vertical stretch or compression happening in your project. Some of you will have something, some of you won't have something. Compression means it got squished down, so it's going to be wider. Like that. So if your A equals 1, nothing is happening. If your A is bigger than 1, that's a stretch. If your A is less than 1, but it's still bigger than 0, okay, it's going to be a compression. So if you have negative 2x squared, okay, the negative tells you it's opening down. The 2 tells you it's a stretch. Does that make sense? It's 2 different things. Positive or negative is up or down. The actual number itself tells you stretch or compress, or nothing. Okay, so it's 2 different things. All right, questions for me on that stuff, on the compress or stretch? Because that's part of your part 5 of your project. All right, ready for our first example? All right, here we go. Example 1. We have a function. It's about a ball that's being thrown off of a balcony of a building. The function given to us is negative 16 t minus 3 over 2 squared plus 136. All right. So S of t equals negative 16 t minus 3 over 2 squared plus 136. It's telling me that my t is time in seconds and that it's showing us the height of the ball after a certain amount of time. Okay? So we're going to determine and explain if this is going to open up or down. So where do we look to see if it's going to open up or down?
The A value.
My A value. We're looking for positive or negative, right? So is my A positive or negative?
Negative.
We have a negative A. We have a negative A. So it's going to open which way?
Down.
So it's going to open down. We have a negative 16, so the negative tells me it's going to open downward. Doesn't that make sense? If I kind of put a picture in my head, here's a building, we're throwing a ball off of it and it's falling down, wouldn't it make sense that it's an upside down parabola? Make sure these make sense. Okay. Let's determine and interpret the coordinates of the vertex of the function. So now we're going to figure out the vertex, and then we're going to figure out what it means. Okay? So inside of here, so that minus 3 halves and the plus 136 gives us our h and our k. What do we always do to h? Change it. So what is my vertex for my h value? Positive 3 over 2. Good. What do we always do with my k value? You keep it. So what's my k? 136. Okay. The vertex in this situation, since we are opening down, the vertex will be the maximum height of the ball. Okay, that's old news. You know that. You know vertex shows us maximum height or minimum height. In this case, it's the maximum height of the ball. So how high in the air did the ball get? 136 feet, right? How long did it take for it to get there? It's a fraction. 3 over 2 seconds, which is 1.5, right? So it took 1.5 seconds to get to the maximum height of the 136 feet. All right. One more question about this. Would we say that this parabola was vertically stretched, compressed, or none of the above?
None of the above.
What is the A value?
Oh, it's negative.
A is 16, right? We have a negative A, and that number is 16. Is 16 bigger than or less than 1?
Bigger.
It is bigger than 1. So since 16 is bigger than 1, we're going to have a vertical stretch for this problem. So because my A value was 16, that number is bigger than 1, so it will be stretched, meaning it's going to be more narrow. It's going to increase and decrease at a faster rate. All right, questions? When we flip the page, we're going to have a new example. So any questions about the ball being thrown off of the building? All right, let's go to the next example. All right, the next one is not a real world thing. What it's doing is it wants us to actually graph this, and we're going to use all of our information that we did yesterday. We're going to use vertex, we're going to use X-intercepts, we're going to use Y-intercepts, and we're going to use the axis of symmetry. So all the things we used yesterday, we're going to use again. Yesterday, there was extra work we had to do, right? We had to do the whole opposite b over 2a, plug it back in, find the y, right? In vertex form, I don't have to do all that. We have a new equation. It is now f of x equals x minus 3 squared and then plus 4. All right, so looking at our new equation, is this graph going to open up or down? Okay, is A positive or is A negative? It is positive. Technically, it's what actual number? It's a 1. Yeah, technically it's a 1 right there. So we do know that we are going to open up. All right, when we had to graph the vertex yesterday from our standard form, we had to do opposite b over 2a, get that h value, plug it in, get my k value, right? There was more work involved. Vertex form, I don't have to do any of that because the vertex form gives me my vertex. So my h piece is being attached to my x, and my k piece is on the end. What do we always do to my h? We always change it. So what's my h going to be? Positive 3. And what's my k value? Positive 4. We also found yesterday that my axis of symmetry cuts through this point. Is it going to cut through the x or cut through the y? It cuts through my x. So our axis of symmetry is going to be that x equals 3. That's the line.
So why wouldn't it be like negative 3 there? On the first one? Oh, the vertex. Why would it be like negative 3?
Because our vertex is hk. Our equation has negative h. So when you take it out, you have to change its sign, is what you have to do. All right, so let's plot these points in my lines. So there's my vertex, right, at the 3, 4. Axis symmetry is the line that cuts right through it. So we should like today a little bit more than yesterday. There's a whole lot of more work we had to do yesterday. All right. After we did our vertex and our axis symmetry yesterday, we did our intercepts. Same thing. So we're going to find my x and y intercepts. We're going to do the y-intercept first. So this is the same as yesterday. If I want my y-intercept, I have to make my x 0. Okay? So the only difference is we have a new equation to do that with. So to get a y-intercept, we have to make my x 0. So it becomes f of x equals 0 minus 3 squared, and then plus 4. If you want the y, make your x 0. Can you stop singing? It's a little distracting. It's bothering me a little bit. Okay, so make our x 0. What is 0 minus 3? Negative 3. Good. Then we're going to do negative 3 squared, which is 9. And what is 9 plus 4? 13. So my y is going to cross my y at 13. So remember, we plugged in an x of 0 to get a y of 13. So my y-intercept is 0, 13. Okay, we plugged in our x of 0 to get the y of 13. So let's plot that. I know it goes a little bit off your graph. It goes up here. It also tells me that if it's possible to plot a reflection point. We did that yesterday. So how could I plot another point without having to plug in numbers? Yeah, move it over. How far away from this are we? 3 over. So let's go 3 on the other side. 1, 2, 3, and plot my reflection point. We also found out that when we factored and solved for my x's, they were always reflection points of each other. All right, my next thing wants me to find my x-intercepts. If I want my x, now we're going to make my y 0. So now it's going to be 0 equals x minus 3 squared plus 4. I want the x, so the x should stay. We're making the other piece 0. We don't have to factor. Yesterday we had to draw the box and solve by factoring yesterday. Today, this should kind of remind you a little bit about complete the square. Okay? When we had parentheses being squared, we were able to square root it, right? There's a little bit difference here. I have a plus 4 in my way. So how could I move the plus 4 over?
Subtract.
Yeah, let's subtract that first. Now it's looking a whole lot like complete the square. To get rid of my parentheses squared, what do? Square root both sides, yes. What? You cannot square root a negative 4. So what does that mean for this one? It means no solutions. Now, hey guys, you knew this the whole time. Isn't this parabola opening up?
Yeah.
So is it going to cross the x-axis?
Yes. Wait, no.
No. Right? If you were to draw, it makes sense, right? It makes sense that we have no solutions because this vertex is opening up and it's already above it. So it will never touch my x-axis. All right, questions for me at all? Hurry. All right, I am not a fan of the taco truck problem that is next. So I would love to not do that. I think it's, in second period, I feel like it confused them more than helped them. So I'm going to learn from that. I don't want to confuse you more. I feel like what we've done so far is really good. So I'm going to pause here. I want you to get out your project paper, please. Your project paper. Okay? So, part 5 tonight, it wants to know, is it being stretched or compressed? So remember, you're looking at your a value. If you just have an x squared, you're not being stretched or compressed, right? Look at the actual number. If there's an actual number in front, like a 3 or a 2, that means it's a stretch, right? If you have a number in front that's like a 1/2 or a 1/3, that is a compression. So that's step 1, okay? Then it's asking you for the domain and range of your graph. So I want to talk about domain and range real quick. Okay? Domain and range, that's the problem I don't want to do. Yeah, we're skipping the taco truck. Okay? Everybody is going to have the same domain. And what do you think it's going to be if we're all having the same thing? What are all the x's you're going to have on all your graphs? All real numbers. Everybody's domain is going to be all real numbers. Everybody. Okay, so everyone's part 5, your domain should be all real. Okay? The range is going to be different for each of you. It depends if you're opening up or if you're opening down. Okay? So if your a value was a positive number, which means your parabola looks like this. Okay? Your range is going to come from your vertex. Okay? Range is your y values, right? So if you're opening up, all of your y values have to be bigger than your vertex. So here you would say my y's are bigger than or equal to my k. Okay? So if we're opening up, my range is that my y's are greater than my k value in my vertex. Okay? If we have a negative A value, meaning you are opening downwards like this. Your vertex is on top. Okay? So when you look at all of your range values, they're all below the vertex, right? So you should say your range is all of my y's are less than or equal to the k value of my vertex. Okay? So that helps you with part 5, and then it wants you to graph it. Some of you have different numbers, so if you change how it's being counted on your graph, the way that it's going to fit the numbers you plugged in. Okay? We did make the equation simple enough where, like, if you used 1, 2, 3, or -1, -2, it should fit on your 10 by 10 graph, is how we created the functions for you. Okay? I'm going to give you your homework, because we have homework and we have project. So project is going to be worked on. If you complete a piece and you want to get a stamp from me today before class is done, you have plenty of time to get more project done today. I'm also going to give you, your worksheet was 2 pages. I'm only going to give you 1 page. Okay? So you'll just get 1 page for your homework to do tonight also. So 2 tests. Do more of your project and work on the homework sheet I'm about to give you. You'll turn in your homework sheet tomorrow. Okay?